Hello there and welcome to this short tutorial video, and in this video we are going to discuss linear motion. Okay, so in physics there is what we call mechanics. It's a topic. So this is a branch of physics that deals with motion. So what is meant by motion? Well, an object is said to be in motion if it changes its position in respect to its surroundings with time. So in this video we are going to discuss 4 or rather 5 important terms that are mentioned under this topic, linear motion, and these terms are, okay, so these are the 5 important terms that are used in linear motion. We have distance, displacement, speed, velocity, and acceleration. So in the exam you're expected to differentiate these sets of words from the others. So in giving an example, you need to differentiate distance from displacement, and differentiate speed from velocity, and thereafter explain what acceleration is and do some sort of calculation afterwards. Okay, so the fact that we've looked at the words that are used in linear motion, we're not going to go into detail to look at what they really mean. So we'll start with distance. Okay, so what is meant by distance? Well, distance is how much ground an object will cover during its motion. How much ground an object will cover during its motion. So there we go. This is actually the total path traveled by an object as it moves from one point to the other. So that's what distance is all about. Well, we can mention to say also that distance is actually a scalar quantity because it just involves the size. Okay, so after looking at what distance is, we can now go on to look at other things that are important about this physical quantity. Distance is actually a scalar quantity, meaning that it only involves the size of the physical quantity. Okay, and the other thing that is very important to mention is that we can measure distance in different units: kilometers, meters, and meters, so on and so forth. But the SI unit for distance is meter. Okay, so that is all we can talk about when it comes to distance. Now we can move on to look at what displacement is and try to see the difference between these two words. By definition, displacement is the change in position of an object. So the change in position of an object in a particular direction, we call that displacement. Alright, so the change in position is referred to as displacement, and we can see that the difference actually is that for distance, we do not consider the direction in which an object moves as it travels from one point to the other, but for displacement we consider the direction in which it moves. So the change in position of an object in a particular direction is known as displacement. And aside from that, because there's direction involved, then displacement is actually a vector quantity. And we can also measure displacement in different units, just like distance. But the SI unit, as you do your calculations, unless the question asks, should be stated in the SI unit. So the SI unit of displacement is also meter. Okay, so we have dealt with these two terms, distance and displacement, in detail. We are now going to look at an example just to see how we can calculate, if there is need for us to calculate for any of these two terms that we are given. Okay, so in our example, we have a particular example. It says the boy started from point A, and I have my point A here, and then he walked 5 meters south, meaning that this direction on the compass shows us anything that is pointing in this direction is south. So the south position or direction from this point is actually downwards. Let's imagine that this is where point B is. Now we are told that this boy actually walked 5 meters south, meaning this distance from here up to here, it's 5 meters. And what else are we told? We are told that when this boy was at point B, he turned 90 degrees and then walked to point C, which is 12 meters to the west. Okay, so if we agree that since this 12 meters is a distance which is 12 meters west of point B, meaning that point C should be somewhere this side, where we are going to say that is our point C. So point C is east of point B, therefore this distance is 12 meters. So therefore we can now conclude that this boy actually started at point A and ended at point C. But in order to get to point C, he had to go to point B, then went to point C. I hope that is clear enough for you to relate with that question. Now that we understand how this boy walked from his initial point to his end position, we can find the total distance covered. By distance, we agreed that this is how much ground was covered as this boy walked from point A to point C. So since he walked this distance and then he walked this distance, then we can conclude that the distance covered was actually 12 plus 5. So we are going to say, for answering the first question, which is distance, will give us the addition of the 2, which is 12 meters plus the 5 meters, which will give us 17 meters. So that's the total distance covered by the boy as he moved from the initial position to the end position. And then the last question says, what is the displacement? Okay, so like we agreed, displacement is just the change in direction or in position as an object moves from one point to the other. So the 2 points which are important here are the start point and the end point. So in actual sense, the change in position for this boy was actually a line that is straight from the start position to the end position. So this is the displacement of the boy. So what can we say then? We can now calculate this displacement. How can we calculate this displacement? We have a situation where we have a triangle there with 2 sides which are known and the other side which is unknown. So we can use the Pythagoras theorem to rather explain this distance here, okay, which was covered by the boy. So how do we do that? Well, we'll need to say that we'll call this distance AC. So our AC squared will actually give us AB squared plus the other adjacent side, which is BC squared. So substituting in the values, AB is 5, so it's 5 squared, and our BC is 12, so BC is 12 squared. And AC is 25, rather 5 times 5, which is 25. And then we have 12 squared, which is 12 times 12, which is 144. And we have 25 plus 144 to give us 169. But this means that I have to find a number that multiplied by itself, it will give me this value, where I will say S is actually the square root of 169. That will give me 13. Okay, so the displacement of this boy was actually 13 meters. Well, the fact that we know that it is in this direction, we can simply state the direction to say southeast to complete it, but it's displacement, so we can really just end it at that point. So this is how we can calculate the displacement in this scenario, and this is how we can calculate for distance, same example that is given. So now we can look to the other two terms, which is speed and velocity, and differentiate them from the other. Okay, now we have looked at distance and displacement in detail. Now we can look at speed and velocity and differentiate from the others, from each other rather. So for speed, this is the rate at which an object covers distance. So the rate at which an object covers distance is referred to as speed. What about for velocity? This is the rate of change of displacement. This is the rate at which an object covers displacement. So I think those distance, definitions are very straightforward to relate. Aside from the definitions, we can also compare the type of physical quantity these two are. So for speed, it is actually a scalar quantity. We are only interested in the size. There's no direction involved. But for velocity, velocity is actually a vector quantity because there's displacement involved there. Therefore, velocity is a vector quantity while speed is a scalar quantity. The two are similar in that we measure the SI unit of the two in the same, which is the SI unit for speed is meter per second, and then for velocity is also meter per second. There are times that you are asked to calculate for speed or to calculate for velocity. So we have formulas to help us to calculate for speed and for velocity. This is the formula for calculating for speed. V is equals to D divided T, where the V denotes speed and the D denotes the total distance traveled. And the T in the formula represents the time taken to cover that distance. So this is how we can relate with the formula. So if the distance is in meters and the time is in seconds, then the SI unit the units for calculating speed would be meter per second, which is the SI unit. In other cases, if the distance is in kilometers and then the time is in hours, then the units for speed will become kilometers per hour. So you need to note, especially on the units as you do your calculations. And the same can be said for velocity, in that the formula for velocity is the S actually denotes displacement and the T denotes time and the V denotes velocity. So the same like we explained here, we can also explain even here. So let's look at an example and see how we can calculate for speed and velocity. We have two examples which we can see how we can calculate for speed. The first one is where there's an athlete T who runs a distance of 360 meters in 60 seconds. And then we are asked to say what is the speed for this athlete T. So we understand that in order to calculate for speed, you apply the formula. So the formula is V will equal to the total distance covered divided with the time taken. So in this case, we can relate that the distance covered by the arithmetic is actually 360 meters. And then the total time to cover this distance is given to equal to 60 seconds. Therefore, if you do your arithmetic, here you find that it's going to give us 6 meters per second. Meaning that in a second, the arithmetic actually covered a distance of 6 meters. Which makes sense, because if you say 6 times 60, we should get the total distance, which is 360 meters. So this is how we can calculate for the speed. You employ your formula and substitute, and then the answer with the correct units. So note here that the units given in meter per second. In the case where they ask you to say convert this speed to kilometers per hour, we'll now introduce to you what we call a converting factor, which is 3.6. This number is a converting factor which we can use in order to convert from meter per second to kilometer per hour, or vice versa. So in the case where we are given meter per second and we want to convert to kilometer per hour, we actually multiply the value that we want to change to kilometer per hour by the converting factor. Therefore, we'll say 6 times 3.6, and this is when we want to convert to kilometer per hour, and we'll get our answer to equal to 21.6 kilometer per hour. So this is how we can calculate for the speed in this case, and where in the case they give you to convert from one unit to the other. I just want to emphasize that this is a converting factor. We use it to convert, not to waste much time from one unit to the other. We move to example number 2, which says there's a car that travels a distance of 50 kilometers in 1 hour. Therefore, what is the average speed? Well, you can still say V is equals to D divided total time. In this case, we are given that the distance covered is 50 kilometers. And the total time taken to cover that 50 kilometers is actually 1 hour. Therefore, 1 hour. Then we can say 1 into 50, that will give us 50 kilometers per hour. I think that was very simple for us to relate. So here in this case, we are given the units of speed to equal to kilometers per hour. What about if we had been asked to convert this unit to meter per second, which is the SI unit? Well, you get your value which we given. Then in this case, we divide it with the converting factor, which is 3.6, and when we divide, we'll get our value to equal to 13.9 meters per second. So there we go. So this is how we can calculate for speed given a question. Mind the units and the convertings where possible. If you're asked to convert from one unit to the other, you need to know how to do that. So we have shown how to convert like that. So we now look at the acceleration and then close our topic. We have looked at speed and velocity. We have differentiated them. Now we summarize by looking at the last term, which is acceleration. By acceleration, we mean the rate at which an object changes its velocity. So when there is a change in velocity as an object moves from one point to the other, we say that the object is accelerating. There are times that an object can be moving with constant velocity, and in that case we cannot say that the object is accelerating because the velocity is not changing. So the only time an object accelerates is when there is a change in velocity. So if you look at the notes given below, you will see what we mean by constant velocity, you will see what we mean by constant acceleration. You just have to read and relate. So in here we are just saying acceleration is the rate at which an object changes its velocity. So we can measure the units, or rather the SI unit for acceleration is meter per second squared. So these are the SI unit for acceleration. So be mindful that if you forget the square root there on the top, then you actually be talking about something else, which is velocity or speed. So we need to be very mindful as we write these units. So the other point which you need to note is that acceleration is actually a vector quantity because there is the consideration of velocity in there. So there are times that you ask a question, you have a formula which you can employ. The formula says that A, denoting acceleration, is equals to V, which is the final velocity, minus U, the initial velocity, and divide by T, the time taken. So the U for the V in the formula means the final velocity, meaning the last velocity attained by an object which is moving from one point to the other. So by that we can also say the maximum velocity attained by that object in motion. Then the U is actually the initial velocity, meaning this is the starting velocity before making motion from one point to the other. So you need to know what the V and what the U actually means, and it's V is minus U, not U minus V. And then the T, of course, we relate, this is the time taken. So we have a particular question here which says there's a car that travels from rest and then it reaches a velocity of 36 meters per second in a space of time equal to 8 seconds. So then what is the acceleration of this car? So in this case, and if you read through our notes down there, you will see that whenever you see the word at rest, we actually mean the change, or rather an object is said to be at rest if there is no change in position in respect to its surroundings with time. So by that we mean an object is not in motion. Therefore, an object which is not in motion, its initial velocity is actually 0 meters per second. And then we are told that this object, or car rather, starts from 0 meters per second and increases velocity to 36 meters per second. This means that was its final velocity, that was its maximum velocity attained. Therefore, we can say our V, which is final velocity, is actually 36 meters per second. Then the time taken to change from 0 meters per second to 36 meters per second is actually 8. So our T is 8 seconds. Now we can find the acceleration, which we do not know. So this is one way you can calculate, or rather you can collect the variables that are given in the question, and I advise you to calculate the variables in that order before you make calculations. So this is one way you can actually collect the variables in the question, and I advise you that you collect in that format so that you know how to substitute them in the formula. Now we know that in order to calculate for acceleration, we'll put our formula that says there's our formula, and then we'll just substitute and say our acceleration is, for the final velocity is actually 36. Then the initial velocity is actually 0. And the time taken to change was actually 8. Then our acceleration in this formula will give us 36 divide 8, and finally that will give us 4.5 meters per second squared. So that's how we can calculate for acceleration for an object that changes velocity from 0 meters per second to 36 meters per second in 8 seconds.